Okay, so today I'm gonna try solving this uh, trapping rainwater. The problem with that is that's already solved that today, and even recorded the solution. But this recording was a little bit bad because I didn't manage to capture the window, so it was just still picture with my only explanation, but no like screen sharing. So I'm gonna try solve it again, and yep, let's see how it goes. So the problem is this trapping rainwater, and that's like in 3D, because the previous one was like trapping rainwater one was in 2D, and this one is a little bit complication. So their idea, I have this priority queue solution in mind, and the idea is like a little bit something like that. So let's say we have like 5 by 5 grid. Let's say we have on edge like 5, 3, 4, 5, 3, 5, 5, 5, 5, 5, and then let's have 4, then 5 here, and then maybe 10 here, and then 0 here, 1, and then 11, 5, 5, 5, 5, and then here 4, let's say 8, and then here 0, let's say 2, 11, 2. So the question is, what the amount of water is trapped in this kind of heat map? So the idea is to add all the edge cells to the priority queue, and the idea is to add also the heights of this edge cell, and then get the lowest cell from the edge, yeah, and check its neighbors. Let's say we take 3 here because it's the smallest one, and 3 here is also the smallest one. So check the neighbors, check if they are not in edge, and add them to the queue. And also check the neighbor's kind of height. If the neighbor's height is lower than the current, update it to the current, update it to the current and record the output. Otherwise, just add it to the current height. So like now 11, it's higher than 3, so I just add it to the queue. So now edge gonna be like this one. So all the red cells gonna be the edge cells, like all the cells with a green triangle in the bottom right corner. In the bottom right corner gonna be the edge cells, and then I'm gonna gradually take it, and the one that's already kind of visited and take out of the queue, I'm just gonna cross it out. So we've been on a 3, and now we have 11. We added to the queue, and then we need to take I need to take the lowest from the edge queue. Here gonna be, let's say we take 3, it's gonna be the lowest. I check the neighbors of the 3, they are all edges, so I don't do anything and just cross it out. So next one, the lowest one gonna be 4. So I check again the neighbors. 5 is neighbor, but it's an edge, and then I check 3 is also edge and visited already. So I have like a 0, it's not an edge. So 0 is lower than 4, so I raised 0 to 4. So it becomes 4. It also becomes edge. And I record the result. result plus 4, and then I need to cross out 4. So I need then to take another lowest edge. So the next lowest edge gonna be the 4 I just added. So I check the neighbors. Neighbors like 4 is already edge, neighbor 11 is also edge, neighbor 1 is not an edge, so I expand the 4 because it's lower, so this becomes 4, and then becomes edge, and I record the result plus 4. No, plus 3 because it was 1, yeah, plus 3. And then I figure out like what's gonna be the next next edge. So next edge now is like this, and next edge gonna be again, it's gonna be like let's say we take this 4 because it's also the lowest one. So I check the neighbors. On only one neighbor that's not an edge is 11, so I make it edge. Then I cross 4, and then 11 is greater than 4, then no impact on the result. So next I need to take another edge, let's say 4. I take 4, I check the neighbors, so increase this one to 4, and plus 2, and then increase this to, this stays 5, and then this one also increased to 4, and then the result is gonna be plus 2, and then this is gonna be the edge, this is gonna be the new edge, and this is gonna be new edge, and then I'm gonna cross out this one 4, and so on so forth until like so 4 already here, so they're gonna be all in edge, all edges, no increases anymore, and then all the cells gonna be in edges, and they're gonna be like in a queue, and then I'll gradually will take every edge, and because like all the neighboring cells will have been already visited, so I don't the queue is not expanding and just contracting, and then I'm gonna gradually like remove all this, and the queue gonna be empty, and then I'm gonna exit the while loop, and then this gonna be the result. So like 4 plus 3 plus 2 plus 2, so it's gonna be 8, it's gonna be 11, the total result, how much water I can trap using this heat map. Yeah, so this is the solution. I'm gonna proceed. So I'm gonna have boolean, let's say initial I'm gonna have int rows equals heat map length, int calls equals heat map 0 length, and then I'm gonna go for int I equals 0 I less than rows I plus plus. Then I'm gonna add I'm gonna have this queue, let's say priority queue, it's gonna be int array queue equals new priority queue, and then I'm gonna be accept comparator p1 p2, and then I'm gonna return integer whoever is gonna have the lowest height, and the height I'm gonna store height in under index 2. That's gonna be it. And then for int I, I'm gonna push the, so I'm gonna have boolean is edge matrix new boolean, then here I'm gonna be rows calls, and then I'm gonna add the initial kind of boundary, and then for q that offer new int I0, and then heap map I0, then gonna be if edge I0 equals true, and then q that offer new int I equals -1, the heap I, and then the calls -1, and then for int and j equals 0, j less than calls j plus plus, q that offer new int, and then here 0j, and then heap map 0j, and then is edge, and here I missed is edge. Calls -1, then is edge 0j equals true, and then q that offer new int rows -1 j heap map rows -1 j, and then the same is edge rows -1 j gonna be true, and then while q dot is empty, while q is not empty, I'm gonna do the following. So I'm gonna have the directions array. Okay, let's say and then q dot, and then result also variable, q dot of, or q dot, so int p equal q dot poll, then int heap equals p0, no, p3, next I equals p 0 plus, okay, for int I equals 0, let's say d equals 0, d less than dir's length, d plus plus, and then I'm gonna check if int new next I equals p0 plus dir's 0, dir's d0, and int next j equals p1 plus dir's d1, and then if next I is less than 0, or next I greater or equal rows, or next j less than 0, or next j greater or equal calls, or if it is edge next I next j, then I'm gonna continue. Otherwise if height greater than height map next I next j, then gonna be height map next I next j equals 8, and then q, and then res plus equal the delta, and then I'm gonna have is edge next I next to j equals true, and then q dot offer new int next I next j, and then height map next I next j, and then in the end I need to return as not here, then here, return res. So this is the code for this problem. Let me quickly read that one. So integer compare yeah, something like that. Is not applicable. Priority queue is not applicable. Why? Like this. No, not true. Integer compare p1 and p2. I know. P2 here. Yeah, so this is it. Let me check the timing. Okay, I've been solving that for 18 minutes. There is another solution that basically go from up to down, from like from this corner and from this corner, and basically to kind of consider like this one and this one, kind of this neighboring cells, and like propagate the edge. So in this case it was 5, 3, 5. In this case for 11 I need to propagate the edge 3, and then do all this, and then gradually propagate from the from this corner, do the same. And initially, like as soon as we stop, as soon as I stop, I need to like kind of stop. So it's like multiple iterations were required because like we first go from this side and then go from this side and then from this side. So like in reality, like it can be like here we have say like this. So let's say we have here like 10, 11, then 5, and then here like here we have 4, 3, 2, and then here let's say 1, 1, and then here 0. So what the level should stay here? So if I go from this side, for 0 I should record 5, and then for 1 I should record 1, and then do this. No, I should keep it 2 here actually, 2, and then I need to consider, because I'm changing only internally, so like I need to do this 5. So this changes to what? This changes to 2 because 2 is neighboring, and now I go again from the higher corner. From this corner, if I go from this corner, I'm gonna need to change it again. Yeah. Okay, so like if I so it's gonna be back and forth, minimal changes, yeah. Let me read this problem, how they solve it. So they do go from the top left, and if the so they updating max height, getting max height. So they take minimum of the neighboring, and they kind of either, if it's like the current one is higher, they are saving the current one, but if it's lower, no, if it's higher, they are kind of reducing it. So if the edge, like north or west neighbor, so it has like minimal, and we check for the value itself for the height of the current. If the if the current value is greater, so like what's gonna be in this case? So the mean gonna be 5 and the max gonna be val gonna be 5. If current val 2, so it's gonna be max, so it's gonna be 5. So initially, okay, let's figure out what's gonna happen initially here. So initially we have 0 on the cell, and then for it it's gonna be val gonna be 5, and its initial is true. So vols e, so it's gonna be vols e. Let's say this is gonna be vols e or ig. So I'm gonna save 5 here, and then I'm gonna go to the from down right, so it's gonna be 2 and 4, and again vals here gonna be 2, and then if vals it's greater, if vals eij is greater than val, then val gonna be changed, vals e gonna be changed to val. So this changes to 2, and update is equal to, okay, we go again here. So here the val is equal 5 that we need if vals e g ig is greater than val then, but it's not greater. Okay. So So first pass we're gonna just updated based on what the minimal here on the top and on the left neighbor. And on second pass, starting from here and then further from here and there, if we like new suggested value is lower than the current one, then update it. So initially it's like optimistically updated, and then if a new value, update value is lower, then update it. If not, then stay whatever it is. Yeah. Okay. I wonder if I drop this up. Okay. Probably there are some edge cases. Okay, if I gonna do this, so from a scratch, if I remove this one and I do so initially need to remove this one. There we have int a new integer rows calls, and then for and boolean init equals true, boolean update equals false, while init I do for int I is equal 1, I less than rows minus 1 equals plus for j with 1, j minus calls minus 1, j plus plus, and then val equals max height map height j, and then math min whatever is well, j, and then val I j minus 1 if init or val less than val eg, then I'm gonna update vals ij equals val, and then init equals false, then update equals true, and then here the same, but for j is equal n minus 2, like rows minus 2. For j equals calls minus 2, j greater than calls greater than equal 1, j minus minus, Okay, and then here interest 0, empirical 0, for int I equals 1 other than -1 plus for int j equals 1 j other than rows. Oh, here are rows. Called -1 j plus, and then here s plus equal max 0 was ij minus 8 map ij, and then return res. Will it work? Compile error, boolean update, date equals false. Okay, so initially I need to also update for int j equals 0 j less than calls plus say was ij equals 8 map ij. Oh, okay. No, the same. Okay, will it work? Yep. Okay, that's pretty much magic, I would say. I kind of understand why it works, but like probably some formal proof is needed. I wonder how many eyes are here, how many times we updated. Say if you have a private static int counter equals 1, and if I gonna just system out println counter solution.counter, it's gonna be counter 1. Oh, okay. Okay, how I can, yeah, so I can save the check what the number, what's the test number, so I kind of fail But let's say I fail, like, let's say at test number 42. Okay. Okay. Driver solution, helper. Java print system info. What if I do this? Will it work? File. File. Java import file. Okay. Okay, course. Total memory available bytes. So it's kilobyte, 16 gigabytes. Kilobytes, megabytes, 13, 20, even more, 24. But I don't know, like, what that, is it like swap? Can read, get absolute path. Interesting. File. The file. What if I do this? System out println file get absolute path. Okay, what it will say? Okay. Access denied. Interesting. Access denied. Driver. There is some driver. What does it mean? Security. Java print JVM JVM stats. read file from create file Java. Okay, let's do this. Can I create file and read and write the number file name? Ah. I need definitely remove that file first. Where is my obj? My obj already defined. Okay, here. Run. Access denied. Can I create file C? At least no, like this. Create file. If I create it in TMP. If I create it like this, TMP. Can I do that? Can I update write a variable into JVM? Let's check. Say home. Oh no, Java pass. System out talent. And then value. Okay. Everything is denied. Oh no, okay. Across launches. And cross launches, okay. Cross launches. How to persuade on JVM? I don't know. This is too hard. Okay, so I cannot track, but like whatever. It took me some time to figure out. Okay, so I'll do the following. I'll do just print the number of iterations. Let's say int counter equals 0, counter plus and then system out println counter plus counter. So counter how many times? Even like 2 times. Okay, that was logical. And here, counter 2, counter 2, counter 3. Okay, so at least there were like 1, 2, like top left, bottom right. So like 2 plus 2 plus 2 plus 2. So it was at least like this while cycle was run at least 3 times. That's interesting. Okay, that's it. I'm gonna, let's say if counter equals greater than, let's say 5, then return, what return? -1. Oh no, no, like this here. Run. Submit. Oh, interesting. 6. Oh wow, that can be even 7. Say 10. We are moving 15, but still it's better than every time doing heap and 20. Oh wow, 25. Let's say 100. Oh, okay, let's say 50. Let's say 24. Okay, 25. 37. $25, $20, $30. Okay, even 28. Okay, so 28 is maximum, or like maybe 27. $27, $26. Okay, so 27 is a number of times this, or like 26, or like, because 20, yeah, 27 is number of this while loop is run in these conditions. Here it's it's like number of rows and calls like 200 maximum. Okay, so that's it. So I'll call this pass because I managed to solve it within like, I don't know, like, need to check the timing, but I feel that I came up with the first solution of heap pretty fast. I guess even within 20 minutes, and then I spent a lot of time experimenting and trying to get the test run number, and then like try to fail it, like, but eventually I managed to use this variable simple counter, and return the false, and that's an empirical way to figure out how many times the while loop was running for the given test cases. Yep. Hope you enjoyed it. That's it.